Hi everyone, in today's lesson we're going to talk about basic probabilities. First, we'll begin with the fundamental counting principle, which states that if there are p ways to do one thing and q ways to do another thing, then there are p times q ways to do both things. What do I mean by that? Here's an example. Miss Mangine goes to the concession stand at Yankee Stadium and sees the following menu. So for entrees, we have 3 options. For sides, I have 2 options, and for drinks, I have 4 options. So in part A, I'm asking to draw a tree diagram to determine how many different options I'll have if I can select 1 entree, 1 side, and 1 drink. Now, the purpose of this course is not for us to draw a tree diagram, so I drew one in here for you, just so you can understand how it works. So the H stands for hot dog, F stands for French fries, Coke, Sprite, water, iced tea. So technically, if I wanted to see how many options I have, we could start with a hot dog with a French fries and a Coke. That's one option. Hot dog, French fries, and a Sprite. Option 2. Hot dog, French fries, and water. Option 3. Hot dog, French fries, and iced tea. So with a hot dog and French fries, there are 4 options going first. So then we could theoretically say, instead of counting all of the rest, hot dog, chips, and then 4 drinks. So hot dog, chips, Coke, hot dog, chips, Sprite. So there are 4 options here. So theoretically, if I wanted to answer the question, I can just add up 4, 4, 4, 4, 4, and 4. Add the pattern. So there's 1, 2, 3, 4, 5, 6. There are 6 sets of 4. So I know 6 times 4 gives me 24. But there's got to be an easier way because I already gave you this tree diagram. Can you imagine doing the tree diagram and then having to count them out? So this fundamental counting principle, what I discussed before, is actually what's going to be beneficial. So what you want to do is you want to map out all of the possibilities of our entree and you want to put them there. Then you want to multiply that by the possibilities of our sides. And then we want to multiply that by the possibilities of our drink options. So how many entree options do we have? Well, we have a hamburger, veggie burger, and a hot dog. So I have 3 entree options. How many sides do I have? Well, French fries and chips. That leaves me with 2 side choices. And then how many drink options do I have? Coke, Sprite, water, and iced tea. So that leaves me with 4. Now, I guarantee if you multiply 3 times 2 times 4, you will get 24. 3 times 2 is 6. 6 times 4 gives me 24. So 24 possible options that I can order. So a tree diagram is really not necessary to figure out total possibilities. So let's use the same scenario. Let's use the counting principle one last time and determine how many different orders I can order without meat. So without meat, well, let's see. Same concept is going to apply. We need to put down all of our entree options. We need to multiply that by all of our side options. And we need to multiply that by all of our drink options. So how many entree options do we have without meat? Well, we only have a hamburger, a veggie burger, and a hot dog. Hot dogs and hamburgers both have meat in them. So I really only have 1 option for my entree, which is the veggie burger. So how many options do I have that don't contain meat is 1. How many side options do I have that don't contain meat? Well, French fries and chips both don't contain any meat, so I still have those 2 possibilities there. And for the drinks, Coke, Sprite, water, iced tea, all of those still do not include meat, so I can include all of those as well. So now if we multiply 1 times 2 times 4, that will actually give me 8 possibilities. So this just goes to show you that if you take away a couple of your possibilities in either of the drink, the entree, or the sides, that it's going to significantly reduce the number of options that you actually have. All right, let's move on to the next page. So let's talk about probability for a second. The probability of an event occurring is calculated by dividing the total number of outcomes by the total number of possible outcomes. So probability can be expressed as a decimal, this is important, or a percent, where all probabilities must be between 0 and 1, or 0% and 100%. So let's take a look at example number 1. It says, what is the probability that a person rolls a die and lands on a number greater than 6? Well, in order to find probabilities, we need to have two things. We need to have the total number of outcomes, and we need to divide it by the total number of possible outcomes. So when we roll a die, we have 6 options. 1, 2, 3, 4, 5, and 6. This is called the sample space. And the sample space is pretty much all of your options, all of your possible outcomes. So of these possible outcomes, how many of these numbers are greater than 6? Well, you all should be saying 0. There are no numbers that are greater than 6. So it's 0 out of 6, which reduces to 0. So the chances of this happening is 0%. Right? There's a 0% chance that I roll a die and I get a number greater than 6. All right, let's try the second example. What is the probability that a person rolls a die and lands on a number less than or equal to 6? Well, let's look at our sample space. 1, 2, 3, 4, 5, 6. Of those 6 possibilities, 6 of them are actually less than or equal to 6. So 6 out of 6 equates to 1 or 100%. So there's a 100% chance that that will happen. So I use these two examples to show you that probability can range from 0% to 100% or from 0 to 1. All right, let's take a look at theoretical probability. Theoretical probability is the probability based on what should happen. So let's take a look at example number 3. Jack rolls a 6-sided die. What is the exact probability that he lands on an even number? So we still need the sample space. So 1, 2, 3, 4, 5, 6. That is my die. And an even number. Well, how many even numbers are in this sample space? 2, 4, and 6. So we say the probability, there are 3 numbers out of 6 that are even. We can reduce that if we like to 1/2. All right, what about example 4? Sarah flips a coin. What is the exact probability that she lands on a heads? So our sample space now is just heads and tails. So we have 2 options, and the probability that she lands on a head, well, there's 1 head. So we're going to say 1 out of 2. And then last but not least, Anthony rolls a 6-sided die. What is the exact probability that he does not land on a 4? So again, here's my sample space. And if he does not land on a 4, that means he lands on everything else, or could land on everything else. So 1, 2, 3, 5, and 6. So we still have 6 options, but only 5 of them are numbers that are not 4. And that would be exact probability. So I've used the word exact a lot here. Exact literally means to express your answer as a fraction. So please, let's write that down. Fraction, fraction, fraction. All right, last but not least is probability of multiple events. So multiple events just means more than one. So what you want to do, if you want the probability of A and B, this symbol here is for and. So the probability of A and B, you're going to take the probability of A and multiply it by the probability of B. So let's look at an example. It says a bag of marbles contains 5 red, 6 green, and 4 blue. What is the exact, remember exact means fraction, what is the exact probability that a person selects a red marble and then a green marble? So this is 2 attempts, right? We're doing one draw and then another. So the probability of red and getting a green. So I'm using the symbols now. So probability of red times the probability of green. That's the formula, right? We take the 2 probabilities and multiply them together. So the chances that I get a red, well, there are 5 red marbles out of what is my grand total? Well, all I have to do is add up the totals. 5 plus 6 is 11, plus 4 is 15. All I did was add up 5 red, 6 green, and 4 blue, get a grand total of 15. And I need to multiply that by the probability of getting green. But what's really important is this word that says with replacement. So that means I've taken the red one out and I've replaced it. So that means my grand total still remains 15. And now what are the chances that I get a green? Well, there are 6 green marbles, so I'm going to put 6 for green. And then all you have to do is multiply these two together. So take a minute, pause the video, type this into your calculator, and hit resume when you're ready for the answer. All right, so you should have gotten 2 out of 15. So that would be my exact probability. All right, last but not least is number 7. Same scenario, the bag is going to contain 5 red, 6 green, and 4 blue. That means my total is still 15. Again, they want the exact probability that a person selects a red marble and then a green marble, but this time without replacement. So that means I'm not putting the first marble back in before I draw the second. So I want the probability of red and green, which means I take the probability of red and I multiply it by the probability of green. So the probability of red is still going to be 5 out of 15. But now I need to multiply that by the probability of green without replacement. So that means the 15 marbles that I had, one of them is being taken out. So now my grand total goes down to 14. The green marbles are still unaffected, so that should be 6. So take a minute, plug that into your calculator, and hit resume when you're ready for the answer. All right, so you should get 1/7. All right, that's it for basic probability rules. If you have any questions, now's a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.